Hi guys, I wanted to go through the practice quiz here, give you the answers so you have a chance to check them before you take your quiz. Also, I want to give you some tips on how to approach this naming table because I think some people are still like, how do I keep this all straight in my mind? And I think that maybe a couple of tips might help you get there or at least improve your chances. Okay, so first off, question number one, what are two types of ions and how do they form? This is what we're looking for, okay? Cations and anions. I know there's more than one way to classify ions, but that is the major way to classify ions. They are either positive or negative. Cations are positive, anions are negative. How do they form? Well, cations are formed by metals losing electrons, okay? Metals losing electrons, okay? We do want you to know that it's metals. We do want you to know they lose electrons, and we do want you to know that they're positive. Okay, so I didn't write that on here, but they are positively charged. Okay, anions are nonmetals gaining electrons, and they become negatively charged. So please know all of those things for us. Okay, number two, what does the Roman numeral signify in the name of the compound? Okay. The Roman numeral, if you see a Roman numeral in a name, which we don't have any on this page, of course, but if I have something like iron 3 chloride, that is there because I have a transition metal and we need to know what charge that transition metal is, okay? So the 3 tells me the positive charge of a transition metal. So it's the charge of the transition metal. It is always positive because it's always a metal and metals are always going to be cations, okay? So Roman numerals tell us charges of cations when we don't know what their charge is by looking at the periodic table. Number 3, describe two differences between acids and bases. A lot of different ways you could take this one. In the book, they talked about pH. So pH of acids are less than 7. pH of base is greater than 7. Okay, neutral is 7. So that's one difference. Okay, if you just say pH of acids is less than 7 and pH of bases is greater than 7, that's only one difference. You're not getting the full credit there. We need two differences between acids and bases. Okay. Acids have a different naming system. That's the most complicated part of this section is learning how to name the acids, okay? Bases, they're named just like ionic compounds. That says ionics right there, named like ionics, okay? So acids have their own naming system. Bases are named like ionics. Acids, their formulas start with H. Bases, their formulas end with OH. That's another difference, okay? So pick two and you've got your two differences. All right, number 4, why do covalent compounds have a different naming system? Now, I've worded this in one way, but there are lots of ways to explain this. But you need to make sure that you explain why they have a different naming system. Don't just tell me what's different. Tell me why it's different. Why can't we just name something like an ionic compound when it's covalent, okay? All right, here's what I wrote. Because two covalent compounds can have the same elements, so we need prefixes in the name to differentiate. And then I use an example, CO versus CO2. If we named these like ionic compounds, these would both be carbon oxide, and that would be a problem because this one is highly toxic, okay? So we need a different naming system. The name has to tell the ratio because more than one ratio is possible. So that's a really easy way to explain it. Covalent names have to tell the ratio because more than one ratio is possible, okay? So this one says carbon monoxide, this one says carbon dioxide. So we show that ratio in the name. Okay, you will not have to do nearly as many of the names and compounds on your quiz as are right here, okay? But I want to go through kind of a tip on how to approach this, okay? When you have 4 choices of compounds, it's really easy to accidentally label something incorrectly. So I would say go in order of the types of compounds. Find all of your acids first and label them acid. Okay, so what do we look for an acid? Well, we look for hydrogen at the start of the compound or literally the word acid in the name of the compound. So if I'm looking at these compounds here, First thing that starts with hydrogen is this one, H2SO3, so that's an acid. Okay. Next one is HNO3, acid. HBr, acid. Hydrochloric acid. If you don't label these ones acid, you're not paying very close attention, okay? All right, so there's my acids on the front. Bases. Remember, for bases, we're looking for OH, or we're looking for the word hydroxide, right? Because that's what OH is. So we're looking for OH or hydroxide. This is for base. Acids are H, okay? All right, so here, OH right there, so base. This is oxide, not hydroxide. Be careful of that, okay? OH, base. Again, trioxide is not hydroxide, so make sure that you're careful of that, okay? I'm gonna go ahead and do the back too. Get this out of here. All right. Acids first. Remember, we're going in order. Acids. So we're looking for the word acid, no acid, or the H at the beginning, acid. H at the beginning, acid. Okay, bases are second. We're looking for hydroxide. This one is hydroxide, so base. And that's the only other hydroxide on the page. All right, back over here. Next is ionic. Now, ionic, we're going to look for a metal. We're looking for a metal at the start. Remember, it's going to start with a metal or NH4, ammonium. Okay, so carbon is not a metal. Strontium is a metal, so that is ionic. Barium's a metal, but remember, that's why we went in order. Okay, we already labeled this one base because it is a base. It's a special kind of ionic compound, so it is a base. Okay, that's why I want you to go in order, because then you won't accidentally label this one ionic. Lead is a metal, so this is ionic. Not a metal. This one has prefixes, plus phosphorus is not a metal. Okay. Cobalt is a metal, ionic. Disulfur, sulfur is not a metal. Aluminum is a metal, ionic. Sodium is a metal, ionic. NH4, there it is, okay? It's either got a metal or it's got NH4 at the beginning. That one is also ionic. Remember, all of our covalent compounds are made out of 2 elements right now. This one has 4 elements. It is not covalent if it has more than 2 elements, okay? CCl4, that one is not a metal, so that one's going to be covalent. Okay, so now everything that's left is going to be covalent because I've already covered all of my other types of compounds. So I can just go through and write covalent next to all of those. Okay. Okay. Now I'm just going to go through the names real quick. I already wrote them over here, so we're just going to use this. I'll try to zoom in a little physically. All right, so hopefully we can read that. This first one, covalent, remember, has prefixes. So carbon, there's only 1, tetrafluoride, 4 fluorides, okay? Ionic, you just name the first, name the second. So this is strontium iodide. Remember, the ending of that second element is going to be "ide" unless you have one of the polyatomics, okay? Okay, that's a little bit better. Okay, barium hydroxide. Remember, these ones are named just like ionic compounds, so barium hydroxide. All right, acid, this one right here, that is sulfite. Sulfite, okay? Acid names, the little name tricks we taught you. Sprite is delicious, so ite is delicious. So ite becomes us. So sulfite, you could write sulfus acid just because we're beginners. We don't really necessarily know. Sulfur's root is actually the whole word sulfur, so sulfurous acid. But I will be looking for the proper ending, okay? PbO2, ionic, so we just name the first, name the second. This is lead 4 oxide, and we need that Roman numeral because it's a transition metal. And the way we come up with that Roman numeral, well, if you just went like this, oh, lead's a +2, okay? That is not correct because that only works if this part is true. There's a 1 implied right here. If I bring that up, it tells me that oxygen is a -1. But if we look at the periodic table, oxygen is not a -1, it's a -2 because it's 2 away from being stable. So since I have to change that to a -2, I have to double it. I have to double this charge as well. So that's why we get a 4 right here. All right, this one, another acid. This is nitrate. Nitrate. Remember, I ate something icky, right? Ate ick. So nitrate becomes nitric acid. Don't forget the word acid. At least write the word acid if you don't remember your naming rules, okay? Br is bromide. Bromide. Okay, because it's just bromine with a negative charge. Bromide. Ide. My ride has hydraulics. Okay, hydro and ick are both part of that one. Okay, so ide becomes hydrobromic because this is bromine, hydrobromic acid. Covalent, we're going to use prefixes. So prefix for 4 is tetra, tetranitrogen. Remember that first element just keeps its name. We don't change the ending. Tetranitrogen. 6 sulfurs is hexasulfide. Second element does change the ending. Base, name it just like ionic, sodium hydroxide. Hydrochloric acid. Okay, so this one's going backwards. Hydroic comes from my ride, has hydraulics, which means that this is from chloride. Well, chloride is a 1-, okay? All acids start with hydrogen, and hydrogen is a 1+. So HCl, because a 1+ and a 1-, they balance. Covalent literally tells you the formula in the name. Diphosphorus is P2. Trioxide is O3. All right, up at the top of the next page, cobalt-3 sulfide. So this is a 3+ charge on the cobalt. Sulfide, you look at the periodic table, is S2-. Then you have to balance by switching those charges to make the subscripts. So we get CO2S3. Iron 2 hydroxide, again, that 2 tells me the charge of the iron. It is a 2+. We need to know hydroxide, OH-, just a 1-, okay? So FeOH2 is going to be my formula. It does need parentheses, otherwise you have 2 hydrogens. You want 2 hydroxides, which includes the oxygen. Covalent, disulfur decabromide, 2 sulfurs, 10 bromides, S2Br10. Ionic, we need to use charges. Aluminum's charge is a +3 when you look at your periodic table. Okay, it's over here. It's going to lose 3, become +3. Sulfide's at -2 again, so Al2S3. All right, ionic. When you have ionic and it's got lots of elements, you need to divide it, okay? We label this one ionic because it has a metal, and then this whole thing becomes the anion, okay? Cation, anion. Cation is sodium. Anion is one of your polyatomic flashcards, bicarbonate or hydrogen carbonate. Okay, so sodium bicarbonate or sodium hydrogen carbonate. Same thing here, cation, anion. It doesn't matter how many there are. We're going to look at these as 2 polyatomic ions, ammonium sulfate. Another acid. Right there, CN, one of your flashcards is cyanide. Cyanide ends in IDE. My ride has hydraulics. So hydroic with the cyan in the middle, hydrocyanic acid. Hydrocyanic acid. Covalent, the name tells us the ratio. So we have 1 carbon, that's just carbon. 4 chlorines, tetrachloride. Tetrachloride. And acid, this is nitrite. Sprite is delicious, ite us. So nitrous acid. Okay, so that's the practice quiz. I just wanted to make sure that I showed you kind of my technique again. I would say label all of your acids first, then your bases, then your ionics by looking for the metals, and then everything that's left is covalent, and that might help you not mix them up, okay? So hopefully we've got our naming systems down. Please ask questions before your quiz if you have them, okay? We will see you in class, and good luck.